This is 1.1 exercise, 6th question we are doing. In this 2 bits are there. The first bit is 242 over 1000 they have a given. Okay. So decimal form. This is a rational number and you need to convert into a decimal form. Already we have learnt in previous classes. If a denominator contains a number of zeros, then dividing means what? It's a decreasing. So you need to move left side that many numbers, that many digits. So first write the numerator as it is 242. Our denominator is containing 3 zeros. So you need to shift the point. You need to put the point after the 3 digits. So 1, 2, 3. So let's put a point here, decimal point. So nothing is there in front of the number. So we can put this as a 0 here, right? Second question. 354 divided by 500. Okay. So how can we do this? 354, we will mention it as a 5 into 100, okay? So we can write it as a 5 into 100. So 354. This can be done in two ways, Ayesha. One is simply dividing 354 divided by 5, but 354 is not completely divisible, right? Because in one's digit we have a 4. So according to the divisibility rule of 5, we should have either 0 or 5. So we can't completely divide this. We will get decimals only. So one more way is, another method is, see here 5 is there. I want to make it as a 10. So I can multiply the numerator and denominator with the 2. In the denominator I have a 5. So how much number I choose and multiply this number to make it as a 10? What is the number I can choose?
2.
2. So if I multiply both numerator and the denominator, then we will get a number of zeros. So I am multiplying 354 times 2 by 5 into 100 times 2. Again, if 2 get cancelled, means same number you are getting. Okay. So just one type of equilateral fraction only it is. Okay. Equivalent fraction only. So 354 2s we will multiply. 2 4s are 8. 2 5s are 10. 1 is a carry. 2 3s are 6 plus 1 7. 708 by, now multiply 5 2s are 10. So that is equal to 708 by 10 into 100,000. Okay. 10 into 100 is 1000. So now it is easy for us to put a decimal place. In the denominator, I have a 3 zeros. So where I need to put the decimal place? Where I need to put?
After 3 digits.
Yes. 1, 2, 3. So leave 3 digits and put a decimal place and put 1 0. So without dividing actually also, by using some small tricks, we can do in this way, division. Third question. 2 by 5. In the denominator 5 is there. So with which number I can multiply so that I can get 10? 5 is nearest to the 10. Which number?
2.
2. So 2 over 5 times 2 by 2. So 2 2s are 4, 5 2s are 10. So when our denominator contains, it is easy for us to make them into a group of tens. Okay. So 4 by 10 is nothing but just write the 4 in denominator. We have a 1 0, leave 1 digit and put a point. Okay. Next, fourth bit, 115 over 4. Okay. So 100, see in my concept video, I already explained you that. So whenever our denominator contains 2, 5 or both 2 and 5, we can write them into a terminating decimals. Okay, so 115 by 4. So 4 can be written as 2 square ma. Yes, 4 can be written as a 2 square. So to get number of zeros in the denominator, I need to multiply with the 5 square. When only 2 is there, I need to multiply with, because 2 5 is 10. If they have a given a 5 in the denominator, we multiply with the 2. If we have a 2 in the denominator, we need to multiply with the 5. Just opposite. So here 2 square is there, hence we will multiply with the 5 square. 115 by 2 square is a 4. 5 square is a 25 by 25. So let's multiply with the 25. Table is easy. 25 5 is a 125, 12 is a carry, 25 1 is a 25, 25 plus 12, 35, 36, 37. So 3 is a carry. Again 25 1 is a 25, 25 plus 3 is 28. By 25 4 is a 100. We already know that 100. So could you give the answer for this?
$28.75.
Yes, 28.75 is the answer. Very good. Understood?
Yes, ma'am.
Okay. Fifth. Now we completed the first bit. Let's do the second bit. Second bit, first question. 2 by 3 is there. See, we don't have in denominator 2 or 5. Okay. And we can't write the given number in the form of base 2 or base 5. So this type of decimals you need to really divide and check. For them, which can be written in the form of 2 and a base 5, we can do in a shortcut method. But for these things, we need to divide originally and we need to give the answer. So let's divide the 2 numerator with the 3. So 0 times, it can't go. Put a point and place 1 0. Now, how many times? 3 6 are 18. 2 is the remainder. Already point is there. You can place 1 0. Again 3 6 are 18. Again 2 is the remainder 20. So 3 6 are 18. So again and again we are getting the same thing. So hence stop doing, and this can be written as 0.666. So we already discussed that after the decimal point, when a decimal decimal digit is repeating continuously and not ending, so what you can write this? 0.6 bar or 0.6 cap. The number which is repeating, so that number should be mentioned with the bar. Only that number. Second question. Minus 25 over 36. Okay, this also we can't represent this number in the form of base 2 and base 5. So this also really we need to divide and check. Put the minus symbol as it is like that. Later we can utilize. Just divide the given 25 number with the 36. So 25 is too small with the 36, 0 times. Now put a point and place 1 0. 36. 36 36 6 3s are 18 it is giving. 36 7s are 7 3s are 21. So let's check 36 7s are how much? 42. 7 3s are 21. 21 plus 4 is 25. 252 it's more ma. So multiply Ayesha 36 6 are how much? Multiply 36 6 are how much?
$126.
6 6 are 36, 6 3s are 18, 12. Yeah, correct. 6 3s are 18, 18 plus 3, 19, 20, 21. 216. Yeah. So 216. Okay. So 6 times 216. 10 minus 6 gives you 4. And 10 minus 6 gives you 4. Here it is a 4. 4 minus 1 is a 3. Right? So 34 is the remainder. It is less. Put 1 0. So 36 tens are 360 ma. So we can take 9 times. 36 nines are 36 nines are 54. 27 plus 5 32. 324. Okay. So 10 minus 4 is 6. 3 minus 2 gives you 1 and 0. Okay, 160. See, if I put here 2, 2 3 is a 6. 4, 4 3 is a 12. It's a near. 12 means near. Here we have a 16, Ayesha. So we need to check. 3 5 is a 15. Right? So either 4 or 5 we can use. So let's check 5. Because 3 5 is a 15. No, 5 5 is a 25. 5 3 is a 15, 16, 17. Greater than this. So let's go for 4. 4 5 is a 20. 4 3 is a 12. 12 plus 2, 14. 140. So we can take 140. 20. Right. 36 fours and I'm so sorry, ma. 36 fours are 144. So 10 minus 6 is 10 minus 4 is a 6, and here 5 is there. 5 minus 4 gives you 1. So this, so 116 and put a 0. Again 160 means we can take 144. Ten minus 4 again 6. Again 5 minus 4 1. Again it is repeating. So hence we can stop writing. So this gave 0.69444, so on. So how can we represent this as a bar?
Zero 0.694 bar.
Yes, bar should be on just 4 only, not remaining decimal places. So this we can call it as a non-terminating. There is no end for this decimals, and also mixed recurring. Few decimals are not repeating, few decimals are repeating. So mixed recurring decimal. Okay. Two more sums are there. In the same bit, we'll do this also. 22 by 7. Okay. So let's divide 22 with the 7. 21. 1. Put a point, 0. 7 ones are 7. 3. 0. 3 times 21. 7. 70. Oh, sorry, 28 we can take now. So 20 means 2 times 14. Okay. So what is the remainder? 660. 60 means 8 times. So up to 3 decimal places enough. Okay. So we checked up to 4 decimal places. So this is giving answer 3.1428. Is it a terminating?
Yes.
Terminating. It's continuous, right? So we call it as a non-terminating. Terminating means we will have a fixed value after doing a decimal, I mean after dividing the number, we'll get a fixed value, no continuous like that. So somewhere it ends, the division ends somewhere. But this is what, so this still we are getting the decimals. There is no end for this. So this is called non-terminating. It's not terminating. The decimal places are not terminating. Terminating means ending. It's non-terminating. And is there any repeated value after the decimal place? Any repeated number?
No.
No. So this is non-terminating, non-recurring. There is no reoccurrence of any decimal value. You got it, Aisha? This is non-terminating and also non-recurring. These type of rational numbers are called as, this type of numbers are called as irrational numbers. These are called as irrational numbers, which are non-terminating, non-recurring. There is no repeated value and also there is no end for the decimal places. So this type of numbers are called as irrational numbers. Hence, they didn't ask us write irrational numbers, but example I'm explaining for you. Next, last question in this bit. Let's divide and check what type of a decimal. Fourth bit is 11/9. Okay, so 11/9, let's divide. 9 ones are 9. 10, 11, 2. Put a point, 0. 2 times 18. 2. 20. Again 2 times 18. Okay. 2. Again 2 times 18. So we keep on getting 2 here. There is no end. So what do we write this?
1.2 bar.
1.2 bar. Correct. Okay. So what type of a decimal this is? Terminating or non-terminating? Keep on coming. There is no end.
Terminating.
It's keep on coming.
Not
no end. Non-terminating. Just little you think and you have to tell till you get habituated. Once you got habituated, then no taking time. Okay. So it's keep on coming means non-terminating. There is no end. Non-terminating means no end. Non-terminating. Just we need to follow with the meaning. And here it is a recurring decimal. One decimal number is keep on repeating. So it's a recurring. It's a recurring decimal. Next exercise, we can do more number of sums so that it will be very clear for you. Hope you understand the session. Thank you. Remaining sums we will do in the next session. Okay.